So in the last few videos, I have used Pnpm as my default package manager instead of the usual suspects. So I thought, why not tell you guys why I'm doing it? I'm sure there are a bunch of reasons why Pnpm is better than npm or yarn, but I'll highlight the most prominent ones, at least for me. Now, at the end of the day, this also is a package manager. A package manager is responsible for installing, updating, and removing software packages and dependencies. So from a feature standpoint, all these package managers are more or less at par. But when you consider efficiency and performance, that's when you start seeing the difference. That probably is the focus here because Pnpm literally stands for performant npm. So I'll individually address some problems that exist in npm or yarn and how Pnpm tries to solve them. So problem number one, npm and yarn both use a very complex dependency flattening algorithm. Now, what does this even mean? So npm and yarn both use flattened node modules. Let me show you what I mean by this. I'll quickly create a node module by typing in npm init. Let me create a folder first. So inside this folder, I'll type in npm init y. Let me go inside this folder. Now I'll quickly install express to this module. So npm install express. Now if I open the node modules folder, you'll see all these extra modules. Express is dependent on all these modules, so we get everything in here. But you'll also notice that the express module that you see over here and all these dependencies are on the same level. Ideally, you should only see express here, and inside the express folder, there should be a separate node modules folder with all these dependencies. But npm and even yarn for that matter flatten the dependencies out. So eventually everything will be at the same level. So there are a bunch of things that npm or yarn needs to consider when flattening out these dependencies. So for instance, resolving deeply nested dependencies, avoiding version conflicts, managing circular dependencies, or even managing peer dependencies. All these factors and probably more need to be considered when flattening out the node modules.
It's too much work.
So it's a complicated and resource intensive task, which in turn takes a lot of extra time. Now the way Pnpm solves this is with the help of hard links, soft links, and content addressable storage. So yeah, big words. To explain this, let me create the same project that I just created using npm, but this time with Pnpm. So I'll cd out of this folder. I'll create another directory with Pnpm. Inside this directory, I'll be using Pnpm this time. So Pnpm init. By the way, if you do not have Pnpm installed, but do have npm in your system, you can install Pnpm from npm directly. So just do npm install -g Pnpm and that should work. So let me do this Pnpm init. Actually, I should cd inside the folder first and then Pnpm init. Now let me go inside the folder. I'll also need to install express. So Pnpm add express. Okay, this is done. But if you take a close look at this piece of information here, you'll see that 64 packages were added. So express and its dependencies were added here in the node modules, but you'll also see that 0 were downloaded. So all the 64 packages that we have were reused. But since it's a new project, where exactly is Pnpm reusing these packages from? From the content addressable storage. So it's literally nothing but a storage on the disk. And anytime you try to install a module, Pnpm first looks for this module inside the storage. If it exists, it will reuse it, or else it will actually download it. You can find the storage location by going inside the node modules folder, and there will be a modules YAML file. In here, you should have a store directory key. Yeah, you can see here. So in my system, this is the store location. Depending on the operating system that you are using, this location will change. You can also configure it, but that's not really necessary for now. So now that we know what content addressable storage is, let's go to hard links and soft links. I won't really go into that much detail here, but a hard link is like a copy that's pointing to the same original source. So take a look at the screenshot. I've copied it from a video that explains the concept in detail. So go watch it to get more clarity. I have linked it in the description. If you have a file, it will essentially point to a block on the disk. When I create a hard link out of it, it creates a copy referring to the same block on the disk. If any of these files change, it will reflect the other one as well. If any one of these files is deleted, the other one will still have the data. Now a soft link is a pointer to the original file. It basically stores the address to this file. So if the original file is deleted, the soft link is now useless because it has nothing to point to anymore. So that's the gist behind a hard link and a soft link. Again, do check out the original video by CBT Nuggets to get more detail on this. So now we know what a hard link is, what a soft link is, and what the content addressable storage is used for. FYI, soft links are also called symlinks or symbolic links. So if you do come across this term, symlinks or symbolic links anywhere else, they basically mean the same thing. It's just a soft link. So now let's see what's happening here. Pnpm has this virtual storage here at the top. If I open this, you'll find all the dependencies at the top level. These are all hard links or copies, and they are linked to the files in the content addressable storage. There will be actual files for these packages in this location. Now, if you go inside any of these modules, so let me just go inside Express, you'll find a node modules directory again, and also all the dependencies for this module. So Express is dependent on all these modules, which is why it's present inside this Express's node modules folder. But these are not actual files. Even though it might look like they are being duplicated, these are actually symlinks. So if you take a look at this icon here, this icon means that all these files are symlinks. These are symlinks to the top level modules here. So array flatten will have a hard link somewhere here. This is a symlink that points to this hard link inside this pnpm folder. So there's always going to be only one instance of the file here. Even if you see that there are two array flatten instances, one here and one at the top level, this is actually a symlink. It's pointing to this hard link. Now inside each of these hard links, you'll find the node modules folder with its dependencies. So I have opened this Express hard link here. We have the node modules folder with all its dependencies. But you'll also find one more thing here. So this module with its node modules folder also has the modules files itself. So Express has all the files related to Express here. And if you notice, it's not a symlink. It's actually a hard link. You don't see the icon here. So the rest of the dependencies that you have inside the node modules will be symlinks. But the actual package will also be part of this node modules folder, and it's going to be a hard link and not a symlink. If I go to any other module, so for instance, let's say call bind, even here you'll find all the dependencies for this module. And at the top here, you can see that this is a hard link. This is not a symlink. So this is actually a copy of all the files that's present inside this storage. Now, if I close this virtual store, you'll also find the Express symlink here. That's because this is a dependency to the project itself. So anytime I install something, its symlink will be added here at the top, and it will point to the hard link that is stored inside this pnpm folder. So this hard link that we have here, not even this, the actual file here, this is what it points to. The symlink that we have at the top level, that is what it's pointing to. If I go back to the npm project, there is no such architecture here. All the modules and dependencies are flattened at the top level inside this node modules folder itself. Now going back to pnpm, this structure does look a little complicated, but it actually solves the complex dependency flattening algorithm problem. In case of npm, as I had mentioned earlier, a lot of factors had to be considered. But now in case of pnpm, each individual module will have its own node modules folder, and inside this folder, it will have all of its dependencies. Each of these dependencies will be symlinked to the actual hard link that is present inside this top level folder. So there is no need to have a complex flattening algorithm here. All the modules and dependencies are encapsulated in their respective folders, linked together with the help of symlinks. The founder of Pnpm also has a great blog post highlighting this very concept with some extra examples. It's an old article, but it paints the picture really well, so do check that out. I have linked it in the description. Now also because of this common content addressable store, in a monorepo setting where you have multiple projects in the same repository that reuse some libraries, the disk space utilization drops down significantly. It obviously won't matter in like regular projects, but it's definitely a plus when it comes to monorepos. I also had read somewhere that when you have a module with multiple versions, Pnpm is intelligent enough to reuse the maximum amount of code by hard linking most of the files from the content addressable store and only writing the new files. So this should also help with the amount of disk space used. One more minor problem that this structure solves is denying access to dependent packages. So in npm, if I try to access anything from any of the express modules dependencies, it will still work. So if I try to import something from debug here, even though it's not a project level dependency, you will see here that the project's package.json will only have express. So this means that it's not a project level dependency, but still I'll be able to import all the exported items from this debug module. It won't even give me any errors and it will work just fine because it's present inside the same node modules directory. Now if Express at any point decides to get rid of debug or move to a new version with breaking changes, next time when there's an npm install on the machine, the node modules will change and anywhere that I have used debug will also break. Pnpm on the other hand won't even let me do this. If you do not have a dependency installed in the project, you won't be able to use it directly. It will give you an error right away and will ask you to install it before using it. And that is how it should be. This is a very minor problem in my opinion because I personally always use dependencies that are manually installed, but someone who's new to the project and is contributing on it for the first time might accidentally use a module's dependency, so Pnpm helps preventing that problem. There might be a few other advantages of using Pnpm in your project, but these are probably the core ones. You can find a lot of benchmarks online to see how performant this is compared to npm or yarn. If it's a small project, maybe it won't make a difference for you to use Pnpm over any of the other package managers, but mid-sized or large monorepos benefit a lot from Pnpm. So yeah, do consider it, and if you have any doubts regarding it, put them in the comments. Also do subscribe to the channel for this type of content, and yeah, I'll see you in the next one.